Hello, good morning, Doctor. I'm Su Dun Heng. Today, I would like to show you my project presentations. Title name: The Effect of the Skateboard Speed on the Aerodynamic Aspect During the Skateboarding. Introductions. Skateboarding is a popular sport provides an avenue to play it. Uh, so, as the student and skater play long time, I believe that there are many negative stereotypes associated with these activities. So, uh, I've I need to create some CFD simulations to solve this problem. So this example skateboard was categorized inlet velocity varies and different turbulent model to run these simulations. For objectives and scopes, we were analyzing the external and aerodynamic aspects around the skateboard bodies. So it will conduct a difference in the velocity and the difference of turbulence flow. Methodology parts, yeah, it could be say the skateboard is make a some make a refinement until maximum 3 because the not limits, so it can't be reached to 5 or 6 somethings. And the geometry is not auto sizes, it's customs, and the mesh also customs. And for the boundaries, it depends on the isometric view of the skateboards. So for the x-axis is symmetry and z-axis is the bottoms. For material points, is also customs, which is out of the skateboard bodies, but still in the domains. So after meshing, it the feature show that the knot limits do not reach 2000 Ks. For turbulence, the laminars and the range will be select except the less. So the model will also select based on the range uh, turbulence. And for the boundaries conditions, the inner velocity is set as with the reference values, which is 20 meter per seconds. For results, the table shows that the inlet velocity, which is 80 meter per seconds, will indicate the highest maximum velocity and the maximum pressures. So for the turbulent models, laminar will indicate the highest maximum velocity. For range, will indicate the highest maximum pressures. Next is a comparison graph. So I have tagged these two graph, which is maximum velocities and maximum pressures. So for maximum velocity versus inlet velocity, uh, is rapidly increased. For turbulence is slightly decreased. So while for the maximum pressures, the inlet velocity increase, the maximum pressure will be increased. So can be seen that is also rapidly increased. So for the turbulence, the first one is laminar, may be higher than the range, or maybe lower than the range. Next is the result of color distributions. So the first figure is velocity. As you can see, a blue areas is more than red areas. So when the skateboard is speed up, we can see the velocity flow around the skateboard. So it's good for the skateboard designs and the performance. While for the pressures, the red areas indicate high flow impact on the head of a skateboard. So need to be take action for this for the head to avoid the cracking or something else. So for discussions, I just make it simple to explain why the reason why maximum velocity obtains. So for inlet velocity variations, so the inlet velocity increase, the kinetic energy will be higher, and with the turbulence models, uh, the inlet velocity increase, the intensity of itself will also increase. So for turbulent models variations, turbulent eddy contribute to a higher velocity, and difference in the maximum velocity lead the specific assumptions and formulations for turbulence flow. Second, explain the reasons for maximum pressures that results obtained. So for inlet velocity variations, the maximum pressure increase depends on the uh, few factors such as geometry and the boundary conditions and the force come from. So it will lead to some drag force when the skateboard when the velocity is increased. So for turbulence models, variations is because the irregulation movement on the air increase the pressures and also due to the energy dissipations and missing effects. In conclusions, the objective was achieved. So there are some future work suggestions. So which are the consideration of a parameter maximum refinement of the skateboards to be improved for better performance. And second, to be ensure the accuracy and reliability of the simulation results. There are small validation and verifications, such as using a grid convergence studies and sensitivities analysis. And last but not least, the large eddy simulation less indicates more advanced and accurate representations of turbulence flow. So that's all for me. Thank you. Bye bye.